we need to evaluate this line integral for the integrand 1 divided by z the power 4 minus 1, having the circle mod z equal to 2. Now if I make the factors of this denominator, I'm getting z square plus 1 into z square minus 1, and then further I can write this as z plus iota into z minus iota, and this to be as z minus 1 into z plus 1. So on equating this denominator equal to 0, I'm getting the points z equal to plus minus iota and plus minus 1. And all these points are lying inside this circle, right? So which means this denominator is covering all these factors for which the points are lying inside this circle, right? So we have to consider fz to be the remaining part, that is the numerator. So this is your fz. Fz is equal to 1, right? If in case I'm having the denominator as z minus 3 into z the power 4 minus 1, then when if I equate this denominator equal to 0, then from this factor I'm getting the point z equal to 3, which does not lies inside this circle. So for this case, I have to consider fz to be 1 divided by z minus 3. So for the factors when equating to 0, the points which are not lying inside the circle, we have to take that factor with the numerator for making our fz. Is it okay? Fine? Alright. So in this example, all the points are lying inside the circle. So we have to take fz only to be equal to 1. So let's start with the solution. So writing this integral as mod z equal to 2, 1 divided by, writing the denominator z square plus 1 into z square minus 1. Making its partial fractions. How to do that? Just write here z square plus 1 and here z square minus 1. When I consider this, hide this from the denominator, we get z square equal to negative 1. Now put this value of z square equal to negative 1 over here. What do I get? 1 divided by minus 2. Right? Similarly the other one. When considering this denominator, hide this from these factors. And when equating this denominator equal to 0, we get z square equal to 1. Put this value over here. I get 1 divided by 2. Yes? So writing here the plus sign and writing here dz. Taking this 1 by 2 common from this and writing the second fraction first minus the first one. Taking this integral inside. Very fine? Okay. So this is further equal to 1 by 2. Okay, this integral, and writing the denominator as z minus 1 into z plus 1. Right? And for the other integrand also, we have to take the denominator as z plus iota into z minus iota. Again, we need to make the partial fractions for this. Just writing here z minus 1 and here z plus 1. When considering this denominator equal to 0, we hide z minus 1 from here and we get z equal to 1 and put this value over here. So I get 1 divided by 2. Similarly for the other one, taking this denominator equal to 0, I get z equal to negative 1. Hide z plus 1 first and then putting this value over here. So I get minus 1 divided by 2. So I can take this negative sign over here. Similarly, we have to take the partial fractions for the another integral. Similarly, we have to take the partial fractions for the second integral. Let's take 1/2 common from this bracket and also 1/2 iota common from this bracket. So I'm having 1 by 2 outside of this integral and here I'm having 1 divided by 2 iota. 2 iota is in the denominator, right? Let's multiply this 1/2 inside this bracket. So I get 1 divided by 4 integration of 1 divided by z minus 1 minus 1 divided by z plus 1 minus 1 divided by 4 iota integral sign, and writing here 1 divided by z minus iota minus 1 divided by z plus iota. Before moving on to the next step, let's manage this negative sign. If I multiply and divide the numerator and the denominator with iota, I'm getting in the denominator 4 iota square, that is equal to negative 4 because iota square is negative 1. So in the denominator I get minus 4, just iota, right? So cancel this negative sign with this sign and I'm getting positive sign for this. And now let's take 1 by 4 complete outside of these integrals and writing all the integrals individually. This is your first one minus, this is the second integral, plus iota the third integral, minus iota the fourth integral. And now we will apply the Cauchy's integral formula to evaluate all these integrals. Okay, we have taken our fz to be equal to 1. Yes, the numerator. And we have z equal to plus minus iota and plus minus 1. All these points which are lying inside the circle, mod z equal to 2. Right? So let's calculate f of z for all these points. So the value of fz at z equal to 1 is 1. It is constant. So all the values are equal. Now since fz is analytic, inside and on the circle, mod z equal to 2. And all these points are also lying inside this circle. That is z equal to plus minus iota and plus minus 1. These lies inside the circle mod z equal to 2. So for these points now we are going to apply the Cauchy's integral formula. So therefore, by Cauchy's integral formula we are applying this formula in 1. From 1 we are having the given integral to be mod z equal to 2, 1 divided by z the power 4 minus 1 dz, which we have split it into 4 integrals, right? Multiplied with 1 divided by 4. The first one is mod z equal to 2. I'm writing f of z for this one. For all these one, I'm writing f of z. For this also and for this also. So these are the 4 integrals. And now we have to apply the Cauchy's integral formula for all these 4 integrals. For the first integral, I'm having fz divided by z minus 1. So here z naught is equal to 1. So when applying the formula, this is equal to 2 pi iota f of z naught is 1. So writing here f1. Similarly, this is equal to 2 pi iota f of negative 1 as the format is z minus z naught. So according to this, we write z plus 1 as z minus minus 1. So f of z naught, that is f of negative 1. Is it clear? Okay, for the third integral, I'm having this to be 2 pi iota f of, here z naught is iota. So writing here iota f of iota. And this is equal to 2 pi iota f of z naught. Here z naught is negative iota. Z minus minus iota. Please remember, for the formula, we are having this format. So here z naught is negative iota. So writing here minus iota. So let's put all these values. So this is equal to 1 divided by 4. We can take 2 pi iota outside of this bracket. And the value of f1, f negative 1, f iota and f negative iota is 1 from here. So this is 1 minus 1 plus iota minus iota. So this is pi iota divided by 2 and all these cancelled out. We are getting 0 over here and that is equal to 0. So we have evaluated the value for this integral to be equal to 0. So the answer for this integral is 0. Okay, thank you. Stay blessed.